Well, hello and welcome to the first video of the year. This is section 3, and then a little bit later we'll do section 4. As you can see, I just put some words up here on the screen for you to remember. There's no definitions, you'll have to look in your book. I do want everybody to pay attention to estimating a square root. Make sure that you can see how to do that, and if you need help, ask a question during class time, okay? Okay, so let's move on to the next. Okay, so here's the part that people said I need to make a video for. These are the different types of numbers. Numbers are broken up into categories. Each type of number fits into a category or possibly categories. When you learned how to count, the very first thing you learned were what are called natural numbers, or we can call them counting. Okay, so counting numbers. Wow, this is bad. All right. Counting. Those are the numbers 1, 2, 3, 4, 5, 6, 7, 8, all and on and on. Then we get into the category called whole numbers. They're the exact same thing as counting numbers, except now we have the number 0. So now we add the 0. That's the difference between whole numbers and counting numbers. Then we have integers, positive and negative whole numbers. Okay, so positive numbers, 1, 2, 3, 4, 5. Whole negative numbers, negative 1, negative 2, negative 3, negative 4. Notice no decimals, no fractions. Now, this actually comes down here. Okay, because that's the next category of numbers. They're called rational. And rational numbers are any numbers that can be put into the form of a over b, where a and b are integers, and b cannot be equal to 0. So anything that can be written as a fraction will be a rational number. So it could be a decimal that ends, I can write that as a fraction, or one that repeats, I can also write that as a fraction. Okay, so that's a rational number. Each one of these, natural, whole, and integers, are called subsets of rational numbers, because I can take each of these, natural, whole, and integers, and I can turn them into fractions. 2 over 1, negative 2 over 1. So it makes it a rational number. Okay. An irrational number is any number that is a square root, or any number that's a square root that's not a perfect square. Okay. The square root of 3 is an irrational number. The square root of 10 is an irrational number. The square root of 4 is rational because it has a perfect answer. Numbers that are decimals that never repeat and never end. So one example is the number pi. Okay, that is an irrational number. So one of the things you have to be able to do is to classify numbers. Notice a number could be in more than one category. The number 15 is natural, whole, and integer, and it's irrational. So if I see a number, I have to remember all of the possible categories. Then I have this number, that's an irrational number. It's an ending decimal. The square root of 57 is an irrational number. Go ahead and figure out what those ones are, and you can check the answers in class. Okay. This is a visual way of representing the numbers. We have all of the real numbers over here. Sorry, all of these are real numbers. Real numbers are broken into 2 parts, the rationals on the left-hand side and the irrationals on the right. Irrationals can't be written as fractions. Rationals can. Within the rational numbers, we have integers, positive and negative whole numbers. Notice that that's a whole number. That's a whole number. We have whole numbers, and then we have natural numbers. Okay? So this is the process that these things go by. Okay, so what we have now is section 4, properties of real numbers. And here's your objective. The first type of property is called commutative. You can see that we have commutative of addition, commutative of multiplication. Commutative just means we can switch the order. Okay, so A plus B is the same thing as B plus A. A times B equals B times A. Okay, so that one's kind of obvious. We saw that a little bit in section number 1 when we were working with p plus 4 and 4 plus p. Those two things are commutative. Then we have associative down here, and basically it just means we group things together differently. So associative of addition, a plus b plus c equals a plus b plus c. So you notice that things are grouped together differently. Same thing applies for multiplication. Okay. Then we have some other properties. We've got the identity properties. An identity property is like looking in the mirror. What do I have to add to a number to get that same number back? So obviously, the answer to that is 0. What do I multiply a number by to get that same number back? The answer would be negative times 1. So a times 1 equals a plus 0 equals a. You can see the examples. Then we have the zero property of multiplication. If I multiply any number by 0, I get 0. Okay. Multiplication property of negative 1. If I multiply any number by negative 1, I get the opposite of that number. Okay. So that's the point of that one. Okay. Now, what you need to be able to do is look at a situation. So for instance, right here in part A, we have 42 times 0 equals 0, and name what property that is. Well, that's the zero property of multiplication. Then we have this one where we've got the parentheses changing, that's associative, and so on and so forth. So you can see that. So I would suggest that you solve these two, 1A and 1B. See what you think that is. What property does that represent? What property does that represent? Then we can use this to do mental stuff. So you can see the example there, and there's a question down here with 3 tennis balls, a box holds 4 cans, a case holds 6. How many tennis balls are there in 10 cases? We're using mental math there. So if, just to kind of point out something, if a question asks you to use mental math, I'm not expecting you to show anything, but it's probably a good idea that you still write something down. Because even mental math can make you go mental. Haha, you see? I did that. I went there, really. I did. Okay. Writing equivalent expressions. Now, here's the hardest part for most of you. They're not asking you to just do it and to write the answer. They're also asking to give the reason why you did what you did. So what they did here is they changed where the parentheses are between the 3 and the n, and they put it between the 5 and the 3. That's the associative property of multiplication. So notice what they're doing for each step. They're changing something to where they can put things close together. So in this case, they flip the parentheses. That's the commutative property. And then they flip the stuff in the parentheses. Then they change the parentheses. That's the associative property. And then they simplified together. Okay, so you can see that. I'd like for you to practice something down here. They all seem to follow the 3 things that you see up above, but that's a good idea to practice. Okay, then we have last thing. Deductive reasoning is the process of reasoning logically from given facts to a conclusion. Okay. It's sort of what police use when they look at a crime scene. They see logical things, they see facts, and then they make a conclusion from there. And then we have the word counterexample. It's an example showing that a statement is false. So if I tell you something like, I always go to the movies on Friday. Well, one Friday I got sick, I didn't go, so that's a counterexample. It makes my statement false. I don't always go to the movies on Friday. Okay? Maybe I'll see you there, who knows? Just kidding. Is the statement true or false? So we see a few examples down here. For all real numbers a and b, a times b is equal to b plus a. All we have to do is think of one example where a times b does not equal b plus a, and that's a counterexample. So we can call this false, and then we come up with an example. And for all real numbers a, b, and c, a plus b plus c is equal to b plus a plus c. That's just the associative property mixed in with the commutative, so that's actually true. Okay. All right. And then here's a practice problem for you. I hope the first video wasn't too bad. Hopefully you wrote down some notes, and I'll see you in class.